All right, we are going to add and subtract rational expressions today. And if you want to remember what you did back when you were younger and you added fractions like 1/2 plus 1/3, what did you have to do to get them to be able to be added? All right, so you were able to add like 1/4 and 3/4. Oops. Plus, because they had the same denominator. That would have been 4/4, which would then simplify to 1. So right here, all of these have the same, well, these two have the same denominator. If this one doesn't, so we had to get a common denominator. If you multiply 2 and 3, you get 6. You would multiply the first fraction by 3, top and bottom, the second fraction by 2, top and bottom. You don't have to write this down. I'm just kind of like making you think before we start. That would have been 3/6 plus 2/6, which would have been 5/6. You add the numerators and keep the denominator. Little review of a couple of things about adding and subtracting fractions. Well, these have the same denominator, so that is the common denominator. So the denominator is not going to change in the answer. What we would do is we would subtract the numerators. So 2x minus 6 would be on top. Do you have a pass then? Okay. Then you would factor the numerator. 2 times x minus 3. And then we have an x minus 3 on the bottom. And then the x minus 3s would cancel because they match identically. So this answer would be 2. I also want to point out a restriction to the denominator. What would not be in the domain for x? The domain, like what can x not be here? 3. X cannot equal, no, the denominator cannot be 0, and the value that would make it 0 is a 3. So you want to start remembering that you can't, there's restrictions to the domain on these problems. So x can't equal 3. What can x not equal on number 2? Quickly. -4. Okay, so x can't equal -4. Now, we're not solving for x right now, so I'm not really super concerned about that, but I want to start. Your homework last night actually had a question that said, what are the restrictions on this expression? And that would be, what would make the denominator 0? That is the restriction. All right, so these denominators match, so we add the numerators. X squared plus 8x plus 16 all over x plus 4. Then you would factor the numerator, x plus 4 times x plus 4, because that's a perfect square trinomial. And one of the x plus 4s would cancel out, leaving you with just a simplified x plus 4. Okay, number 3 is not exactly the same denominator. Very close, but not exactly. They're actually opposites of one another. So we're going to rewrite this. What if you don't change the first one, because I like it as, what the heck, where did I get a 3 from? Excuse me. X minus 5. The second one, if I turn it around and write x minus 5 in the denominator, that's like I multiplied it by -1 or divided out a -1. So I'm just going to change the plus to a minus. And here's why. 5 minus x is equal to -1 times x minus 5. If you want to note that. All right, now the denominators match. We put together the numerators. We get 3x minus 7 all over x minus 5. Not simplifiable, so we're done. Oh, you can't cross out those x's. They're married. I don't know how else to say it. These are married and the bottom's married. They don't match. So you can't simplify it. You cannot cross out those x's. But then we get to this, and I just think this looks horrible. The LCM, least common multiple of polynomials. Same as finding the LCD, which is the least common denominator. To find the least common multiple, though, of 2 or more polynomials, you factor each expression, and the LCM contains each factor the greatest number of times it appears as a factor. Now, I'm not going to ask you to expand this all out all the time. But if you were to look at 16p, what does it say? I can't even hardly read that. P to the second, Q to the third, R. The second one was 40p, Q to the fourth, R to the second, and the third one was 15p to the third, R to the fourth. The way they got the LCD was say 16 is, and they broke it down into 2 to the fourth, and they broke the 40 down to 2 to the second. Where was it? No, it's actually 2 to the fourth times 5. And then they broke down, I don't know where they get that from. That's 2 to, does that say 2 to the third or 2 to the fourth right there? It says 2 to the third or fourth. 2 to the fourth is 16. 16 times 5 is not 40. That's a mistake then. This should have been 2 to the third, guys, right? See what I'm, does it say to the third? I can't, it looks really very fuzzy to me on this worksheet. All right, you guys can see it very clearly on your paper, I hope. All right. That's bugging me to even bother going through this. But here's the point. You want to pick the highest power of each. So I say, look at the P's. You got P to the second, P, and P to the third. So you'd want at least that much P to the third in your LCD or LCM. If you look at the Q's, the highest power of Q would be Q to the fourth. The highest power of the R's was R to the fourth. That's where they got the P to the fourth, Q to the fourth, R to the fourth. And then you mess around with the numbers as well. You can break them down into prime factors. I'm going to move on. You guys a couple of examples here. Let's go ahead and just do some together. So finding the least common multiple for each set of polynomials. We're going to factor out a 2. You'd have 2 times y plus 2. The second one, the y squared plus 2y, you could factor out a y times y plus 2. All right, here's how you find your least common multiple. So your LCM, you need everything there is in the first set. So I need the 2 and the y plus 2. Then look at the next set and say, is there anything different? Anything that I don't have written down already that's in the second factorization? Y. So you need a y also. Then I would probably rewrite this to 2y times y plus 2. Okay? Yep, that's the LCM. The second one, or 6, factor out an a times a minus 2, and then on the second one, factor out a 5, and you get 5 times a squared minus 4, which can be factored. So I got to take this a second step. I didn't really have to rewrite this one. I need to rewrite this one. A plus 2, a minus 2 is the factored form of a squared minus 4, which is the difference of squares. All right, so now your LCM, least common multiple, needs to have everything in the first one, a times a minus 2. You look at the second one, what's new that you don't have down here already? The 5 and an a plus 2. Okay, I would probably rearrange this when I wrote my LCM and say 5a times a minus 2 times a plus 2. Okay. For number 7, you factor the first one, that'd be x times x minus 3. The second one, you factor as x plus 7 times x minus 7. The third one, you factor as x plus 7 times x minus 3. Okay, to find the LCM, I'm going to put commas between there because I want you to realize those are separate things. Okay, take everything in the first one, which is x times x minus 3. Take anything new in the second one, which is all new. So I need an x plus 7 and an x minus 7. And then I look at the third one and I say, do I have anything more that I need to add on to this? And since those are both already here, we don't want another one, right? You want the least amount, or the most that appears in any one factorization. If either of the factorizations had an x minus 3 and an x minus 3, you'd need both of them. Okay, so sometimes there are doubles of the same thing, but that's only if it appears more than once. And I'll show you what I mean by that going forward. All right, so again, I already showed you an example of then and now, so let's just move on to the steps here. To add and subtract rational expressions, follow these steps. First, you find the least common denominator, LCD, which is what we were just looking at. It's like doing an LCM. You rewrite the expression with the LCD. You add or subtract the numerators, and you keep the denominator. You combine any like terms in the numerator, and you factor if possible, and then you simplify if possible. First example. We close the door, please? Thank you. Factoring the denominator here, we got 2 times x squared plus x minus 6, which factors. And that would factor to x, thank you, plus 3, x minus 2. The second one factors to x minus 2 or x plus 2, doesn't matter what you put first, x minus 2, one of each. And then we say, okay, what's the LCD? Least common denominator would need to be everything in the first one, 2 times x plus 3 times x minus 2. I look at the second factorization and I see that there's one new thing, and that's the x plus 2, so I would have to add that on. Okay, it's going to take a little work here. It's a pretty darn big denominator, right? All right, so keep in mind what you factored for the first fraction, what you factored for the second fraction, so that you can do the problem. So what I'm going to show you, I'm going to make one big bar. I'm going to put my LCD on the bottom. Okay, now, the first fraction has a 6 in the numerator. So I'm going to write down the 6 because I have to combine my fractions. So I'm going to show you how, okay, if this doesn't work, I will back up and show you that, here, I'll say it right now. If you look at the denominator, what does this denominator not have that the new one, the one we want, or the LCD does have? What's missing from here that we need in our LCD? The x plus 2. So what you're actually doing to this fraction, you're multiplying it times, I don't want to put that in a different color, times x plus 2 on the top and on the bottom. So its denominator would actually be that whole thing. And I'm only going to do this once, and then I'm going to start doing a shortcut. Okay? And then the second fraction, what would you need to multiply it by? Well, it's missing the 2 and the x plus 3. So I'd have to multiply it by 2 and x plus 3. And then it would have this whole denominator under there. Do I need to write it? Probably not. I could skip that. Okay. So here's what I want you to do for your problems. I would like to see you write 6 times the x plus 2 in the top. Oops, my pen, I had an eraser instead of a pen. All right, and then bring your minus sign, and then the 2. And then I have to multiply that 2 by what's missing from its denominator that's in the LCD, 2 times x plus 3. Okay? All right, now I have to distribute and do a bunch of stuff here before I'm going to be finished. So I'm going to distribute 6x plus 12 minus, that's really 2 times 2 is 4. 4 times x will be minus 4x. And minus 4 times 3 would be minus 12. And it's still all over that big denominator, 2 times x plus 3 times x minus 2 times x plus 2. Okay, next I need to combine any like terms. Like terms are 6x minus 4x is 2x. You can put it out there. And then 12s cancel each other out. So now I'm down to this. Anything left for me to do? I got a 2x on top. Do I have a 2 or an x on the bottom? I do. So I can cancel out the 2's. And my final answer for this problem is x over x plus 3 times x minus 2 times x plus 2. Okay, let's try some more. These are a little more tedious than what we did yesterday. But it's still related because we did some of this stuff yesterday where we factored and simplified. Okay, a little bit simpler one on number 8. What? No, no. It'll get way too big, way too messy. What would the LCD be? Well, I need a 7x. The second fraction is 7x times 2, so I need a 2. The second one is 3 times 7x, so I need a 3. You with me? So I had a 7x, a 2 times 7x, and a 3 times 7x. So we need to have the 7x, the 2, and the 3 in our LCD. If you keep it broken up like that, it can help you decide what to do to each of your fractions. I'm going to rewrite these fractions because I want to make sure you're following where I'm headed. Okay, now I'm going to look at them and say, well, what do I have to multiply each fraction by to get the LCD? Well, the first one only has a 7x, and I need it to be a 7x times 2 times 3. So 2 times 3 is, so let's multiply this one by 6. Well, I can do it top and bottom. Doesn't matter where I write it. So I'm going to write it on the left so it's easier to see. All right, the second fraction, I have a 14x. That takes care of the 7x and the 2, so I need to multiply the second fraction by 3. Top and bottom. Doesn't matter where you write it. And the third fraction has the 7x times 3, so I need to multiply it by 2. Top and bottom. Okay, so after this one example, I'm not going to write as much. I'm going to try to show you a step to skip. All right, so this would be 12 over 42x plus 33 over 42x minus 4 over 42x. Now that they all have common denominators, we combine the numerators. So your actual problem is 12 plus 33 minus 4 over 42x. Go ahead and do 12 plus 33 minus 4. And that comes out to 45 minus 4, 41 over 42x. And that's done. My goodness, by now, finally. Next, we have number 9. And I'm going to factor the denominator of the first fraction. So that'd be 6 times y minus 2. Oh, that's nice. The second one has a y minus 2 in it. So my LCD would be 6 times y minus 2, which means I only have to do something to the second fraction. So I have to multiply the second one by 6. All right. It doesn't have a 6 in its denominator. You need the LCD to be 6 times y. So here's what I'm telling you about a shorter cut. Ready? On the bottom, I'm going to write 6 times y minus 2 for my denominator. My numerator, I didn't have to do anything to the first fraction, so I write down the numerator 3y minus, and now I'm going to do 2y times 6, which is 12y. All right, now I do have something I could factor out in the numerator, or I can simplify it, right? 3y, what? 3y minus, well, hold on, 3y minus 12y, they're like terms. Let's simplify it first. 3 minus y minus 12y is negative 9y over 6 times y minus 2. Okay, here's where we make mistakes. You cannot cancel out those y's. The y minus 2 is married. They're stuck together. This y is single. The negative 9 and the 6 are like single. They're just multiplying stuff. We can reduce the 9 and the 6. Okay, so what can we reduce that by? Dividing by 3, top and bottom. So this is going to be negative 3y over 2 times y minus 2 in parentheses. That's finished. Okay, so I always call them married. Don't try to separate them. You can only cancel products, things that are multiplied, whole terms. So with that in mind, you can't factor anything on the denominators of number 10. So what I do is I multiply the first fraction by the second denominator, and I multiply the second fraction by the first denominator. Because the LCD would be x plus 6 times 2x minus 3. You have to use both of them. So I'll multiply the first one by 2x minus 3, top and bottom. That's what you're doing. The second one by x plus 6, top and bottom. And I'm going to go ahead and go for it. So I'm going to write one fraction bar. I'm going to put my LCD on the bottom. I'm going to say, all right, in the numerator of the first one, 3, I have to multiply by 2x minus 3, plus 5, I need to multiply by x plus 6. Are we okay? I don't want to be going too fast. I'm hoping I'm not going faster than I went second hour. Slow down a little bit, okay? All right, now I'm going to go ahead and distribute and simplify. So I'm going to have 6x minus 9 plus 5x plus 30. And then my denominator, you could do some simplifying instead of writing your denominator over and over again, but the final answer, well, maybe not. I got to check if it's factorable. I need to add my 6x and 5x would be 11x. Oh yeah, negative 9 and 30 be plus 21. And then the denominator, x plus 6 times 2x minus 3. Oh, I can't factor that numerator, so we're done. Okay, anybody still need this? Okay, ready? All right, number 11. Factoring the first denominator, you would factor out an a. That'd be a times a minus 2. The second one would be a minus 2 times a plus 2. The LCD, a times a minus 2. I look at the second denominator. What's new is an a plus 2. There's my LCD. The first fraction's denominator is not have the a plus 2, so I'm going to be multiplying a plus 2 times the top and bottom of that fraction. And the second one doesn't have an a, so I'll be multiplying times a, top and bottom on the second fraction. With me? It's okay? Does everybody understand this step? Any questions about what I'm doing the first step here? All right, no? All right. Fraction bar. Put the denominator down there. And then I'll look at what I got to do in the numerator. I just don't ever want to forget my denominator, because if you don't write a denominator, you're not going to be getting anywhere with these. All right, I need to do 10 times a plus 2, and I have to subtract 5a. You could skip this step and go to 10a plus 20 minus 5a. And then you could write 5a plus 20. Now, I just don't want you to get lost. I'm simplifying my numerator right now. I'm going to rewrite the denominator because it better be there. If you forget to write it, it's going to be a marked wrong problem. Okay? Multiply what? Because it already has an a minus 2 in this denominator. So I only multiply by what it's missing. Okay? Are you all right now? Okay, then is there going to be a point to factoring that numerator? Yeah, we could, but will it do anything? Well, if we factor out a 5, we're going to get 5 times a plus 4. Will anything cancel? No, so we don't need to go any further. So if it's not going to like help you reduce it, there's really no point. It wouldn't be wrong to have it factored though. Okay, does anybody still need this? Oh, all right. So 12, the LCD. I need the 3 times the B times the C. Then all I do is look at the next denominator and I see there's a 5, so I need it. Because 5 and 3 are not common to one another. They're different. One doesn't divide into the other. And I don't have an A, so I need an A. I already have the C. So I'm going to take 4A and multiply it by what's missing, which would be the 5A. The first fraction needs to be multiplied by 5A. The second one needs to be multiplied by 3B. Okay, so I might as well not write what I was about to write unless you want me to. Minus 15B times 3B. That's essentially what I'm doing. And on the bottom, I will have 15 ABC. All right, so I've got 20A squared minus 45B squared all over 15 ABC. What are all of these divisible by? Every number up here. So you can do that. You could factor out the 5 and then reduce, or you could just do divide by 5 everywhere, each term. If I divide by 5, that's going to be 4A squared minus 9B squared, and on the bottom, 3ABC. No point in factoring that difference of perfect squares because it won't simplify anything. And you cannot cross out any A's and B's. These guys are married. Okay. I know that's a weird thing to say, but I don't know how else to try to make it some kind of weird thing to say to make you think about it. Okay. Number 13. This would be n minus 2 times n minus 3. And this one's n minus 3 times n plus 3. So the LCD, you need an n minus 2, an n minus 3, and an n plus 3. So what's missing from the denominator of the first fraction is the n plus 3. So I'll have to do times n plus 3 for the first fraction. I don't know where you want to write it, but anyway, you don't have to. But the second one I'm going to have to multiply by n minus 2. Okay. Just going to write my denominator. My numerator, I'm going to have to do in parentheses 2n minus 3 times n plus 3. And if you can go ahead and multiply that out right away, that's fine too. Plus 5 times n minus 2. I'm going to keep my steps. I'm going to need to FOIL or double distribute. 2n times n plus 3 would be 2n squared plus 6n, and then I'll have minus 3n. So if I have 6n minus 3n, that's going to be positive 3n. And then negative 3 times positive 3 minus 9. And then I'm going to be careful distributing that minus 5. That'd be minus 5n plus 10. And then I still have my big denominator. Okay, simplifying my numerator, and then I got to see if it can factor. So I've got 2n squared minus 2n plus 1. Right? That looks good. And will that factor? I think I better try to factor it right now. Oh, no. 2 and 1 will never get me a 2. That's not factorable, is it? What's the matter? Question? No? Any questions? Okay, that's it. Can't do anything else on that. And this is 13. All right, 14. Look at that. That's an example of a complex fraction. Isn't that special? What you would do is add these guys, and then you would change that big ginormous division to a multiply and flip that over. So I'm going to show you how to do one. Ready, set? Isn't that looking special? All right, so we're going to pay attention to the top only right now. We're going to add this fraction plus this fraction, just like we've been doing. The denominators are different. X minus y and x plus y are not the same thing. So to do this problem, I will need to multiply this one by x plus y, right? 2 times x plus y. The denominator will be x minus y times x plus y. I will multiply the second one by x minus y. So that's going to be plus 1 times x minus y. This lovely thing right here, that means divide. So what are we going to do to it? We're going to change to multiply by the reciprocal of the denominator. So we're going to change it to multiply, and we're going to flip over and write x minus y over 1. I bet this isn't looking quite as bad now. I hope. Okay, so we've got a numerator to do some simplifying too. I'm going to distribute. So I've got 2x plus 2y plus an x minus y. And then what can I do with this x minus y over here and over here, where they're crossed from one another like yesterday? We can cancel that out because they're identical terms. Okay, it's one whole term. So all I have, on the bottom is x plus y in my denominator now, because I got to replace those with ones, essentially. X plus y times 1 is x plus y. Now I have to see what my numerator simplifies to. Well, I got a 2x plus x, so that's 3x. I have a 2y minus y, which is just y. And then I'll have people who will cross out the y's. No. These are in love. They're married. These guys are in love. They're married. You can't separate them. I know that was silly, but this thing almost looks heart-like, so I left it and I went with it. I've never done that before, where I put hearts by them. Don't know why I started today. Okay, 15. Rewrite this thing. Factor out my denominator. X minus 4 times x plus 1. Second one, x minus 2 times x plus 1. Okay, here we go. One big fraction bar. Put the denominator on it, which would be x minus 4 times x plus 1 times what's new in the second one, x minus 2. The first fraction doesn't have an x minus 2 in its denominator, so we'll need to do 5 times x minus 2. Minus 3 times, the second fraction doesn't have an x minus 4 in its denominator, so we'll have to multiply that fraction by x minus 4. Top and bottom. We'll do some distribution now. Careful, there's a lot of places to make little boo-boos in these. 5x minus 10 minus 3x plus 12. Still got my big denominator. Okay, simplify. 5x minus 3x, 2x, negative 10 plus 12 would be plus 2. Uh-oh. I think we got more to go on this one. Yeah, we can factor out a 2 on the top. So 2 times the x plus 1. I'm showing everything. You don't, if you have a shortened step, that's okay. I can show that I can cancel out x plus 1 because they're both in parentheses. And you're not splitting anybody up. Okay, so the final answer is 2 over x minus 4 times x minus 2. Okay, now comes the longest one of all. I know. Oof. A lot of writing on these. They are tedious, and you have to be very careful and meticulous and write clearly so you don't make little mistakes with your signs and everything else. All right, 16. Here we go. This one factors to x plus 2 times x plus 1. The rest are already factored. The first fraction, so let's write down the LCD. It would be x times, yes, you need that x that's alone. You need the x plus 2, and you need what's new here, which would be the x plus 1. All right, so I'm going to multiply the first fraction by what's not in its denominator, which would be x plus 2 times x plus 1. Minus 2 times, the second one doesn't have an x in a denominator, and it doesn't have an x plus 1. Minus 2. The third one doesn't have an x. So you multiply it by an x. And the denominator is the whole LCD. Step 1. Step 2. Simplify your numerator. Multiply all that out. Okay, we get x squared plus x plus 2x, so that'd be plus 3x plus 2. Multiply by negative 2, that gives me minus 2x squared minus 2x. And then I have a minus 2x at the end. Knowing that I have that denominator, would it be okay with you if I don't write the denominator over again right at this moment? Okay. Just I put the bar there to imply that that should be underneath. All right, so I'm going to simplify. X squared minus 2x squared would be negative x squared. 3x minus 2x minus 2x would be minus 1x. And then I have a plus 2. Okay, now that, you guys, is factorable. I'm going to factor out a negative 1 and show you that that's x squared plus x minus 2. And then I'm going to rewrite my denominator because I don't want us forgetting about it. Okay, now what could I do to this x squared plus x minus 2? I brought the negative sign out, or the negative 1, if you will. This can get factored. Okay, so that is x plus 2, x minus 1. And I bet you know which thing's going to cancel out. Okay, they have to match identically. They are in parentheses. X plus 2 goes out with x plus 2. So, finally, the answer is negative, then x minus 1. And you can put the negative sign like out front of the fraction or on the top. Okay. This is the final example. Your assignment, which I have printed out, and I believe I omitted one question. I made the worksheet, you need to do it.